All right, welcome back to the Neuro Symbolic Channel. So I'm Paulo Shakarian, and I'm here with my colleague Jerry Samari. And today we have a special guest, Matthias Broecheler, um, who we both went to grad school with. And we kind of decided to talk to Matthias today because we were thinking about who has a background, on the symbolic side, but also on the machine learning side, and has been really thinking hard about how we could employ both these ideas for business use cases. So Matthias has had an excellent career since leaving graduate school. He was CTO for a publicly traded company called DataStax. He invented a very well-known graph database that used to be called Titan. What did it end up being called? Did they
I call it
rename?
Janus graph.
Oh, Janus Graph. And now he has a new company called DataScroll. So maybe Matthias, if you want to give some more detail on your background, that might be a nice way to begin.
Yeah, absolutely. Thanks. You did a great job summarizing it. Basically, I've been really interested in throughout my entire career from like research and then in industry, really about how we take data and make it useful for various forms of applications, right? And even back in grad school, there was a big push in ML and being able to do analytics on data and the work on graph structured data was really about like how do we exploit the relationships that are in data in order to do more interesting things with it. And now obviously there's a huge push in AI and Gen AI and how do we take these kinds of models that we're building that are, approaching something like general intelligence and apply them to data, use them with data. What does that look like? And so that's where we're working on right now with the company DataSQRL, where we're trying to figure out how how do the two worlds overlap and augment each other. How do you take the data that you have inside your organization, inside your team? How do you take these foundational models or some fine-tuned models, bring them together and have them do something useful? And so that's kind of where we started. We put out a couple of open source projects along the way where we are openly experimenting with some of these ideas, but we're still mostly in what you call like pseudo stealth mode, where we're mostly just kind of researching ideas, working with a select few customers, trying to figure out what works and what doesn't work in this world to make data useful with AI.
So, um, so as you start kind of doing these experiments and talking with some customers, like I guess, well, even to back up, so like what kinds of companies are these and what are, maybe if you could give some general classes of problems that they're trying to solve.
Hmm. Yeah, absolutely. I think there's so the kinds of customers, I mean, it's a very broad spectrum. I mean, you're talking healthcare companies, logistics, the government, various branches of the government. And the problems that they're looking at are, I think they follow in a couple different buckets. There's this one bucket of one barrier that we used to have for data is how do we do the last mile with data, namely get it to a human and help them accomplish some kind of goal, right? Like so if you think of like decision support system as the general umbrella, right? Like the idea being, how do I take data that I have and make that data accessible to humans so they can make better decisions, right? That better decision could be, how do I deploy resources? What products should we be building? What marketing campaigns should we be running, right? There's like various classes of decisions that are being made, and a lot of those decisions are driven by some kind of market feedback that you're getting, right? And data plays a really important role in catalyzing that market feedback. So that could be, something as obvious as like, okay, who is actually engaging with our product? Who's clicking on our campaigns? What is the revenue that we're making, and how can we optimize it? And how do we help humans make those kinds of decisions, right? And I mean, that's an area of computer science research for, much longer than I've been around, right? Like decision support systems it's been a thing forever. And I think one thing that's really exciting now about this new wave of AI is that we are able to be a lot more empathetic to the user and a lot closer in communication to what a user would expect with natural language text, right? Like if you look at older decision support systems, right? Like usually they were expert systems where you had to kind of know what the system was and how to use it. And, some older systems you had to somewhat be familiar with logics and query patterns and things like that. And so what's really exciting now is that the barrier to entry has been lowered to the point where I can literally just write what I would, or even just speak into the machine, and it can understand what I'm asking and translate that into something that then allows me to pull in the data. And that's really sort of the one side of the equation that we're looking at. And then there's the other side of like, how do we actually use these models to augment your data and to help you analyze your data, right? Like there's been obviously a lot of research on like machine learning and various machine learning models and how do you extract patterns and do all those sort of things. And what's really exciting about this class of models is that, again, they lower the barrier to entry. You don't have to be an expert in machine learning and know what, a random forest is and how decision trees work and Bayesian nets and this, that, and the other thing, and all this sort of rather deep mathematical models. You can say something like, hey, like, take this message and let me know if the user is upset, right? Like you literally write this, and you get like a fairly good sentiment analysis model, right? Like, I mean, you guys know like how much time did we spend in grad school thinking about sentiment analysis, right? Like and like doing word parsing and weighting and like building all these super sophisticated things. And the fact that I can literally now just write, is the user upset? Question mark, and give a piece of text and and with a little bit of prompt engineering, get a pretty good baseline model. That's quite a breakthrough, right? Because it opens the door for applications and for people who are not experts in these technologies to very quickly refine and build out analytics on data that was previously would have taken a lot longer and required deep expertise. And so those are kind of the two classes that we're looking at is like how do we, what I call the last mile problem, how do we get data to the user? And that's really, there's a lot there. And then the other class of problems is how do we enable deeper types of analytics on data without the user having to become an expert?
Okay, so you touched on a couple of different things there. Um, I guess that one thing I'll ask about on kind of the second type of problem, how can you do analytics without the user being an expert? The example you brought up, I think, I think I would agree with that, language models can do tasks like sentiment analysis very well. That's very language focused. But of course, there's other tasks that are more suitable, for something else. Um, do you envision language models, helping kind of glue these things together? Um, how would a suite of analytics be orchestrated in this kind of paradigm where maybe there's like, sometimes you want to do an optimization problem, sometimes, you want a convolutional neural network to answer the question. Sometimes it's just a really sophisticated, query to your SQL database.
Yeah. Yeah, I think there's sort of the obvious first bucket is kind of like what I would call structured data extraction, right? Like you get unstructured text or audio or something, and you're trying to extract structured information, right? And sentiment analysis is one special case of that, where you're trying to basically take text and then get like a floating point number between -1 and +1, right? That indicates the sentiment. And then there's more complicated things like entity resolution and entity extraction and all kinds of other NLP type of problems that are like, give me structured data out of unstructured text. And with these new class of large language models, like we can really supercharge that and extract all kinds of structured information from unstructured data in ways that would have been previously very difficult to do and required a lot of like understanding of neural networks and building your own and such. And I think the foundational models can make that easier. The second thing is that I think the large language models can also help us bridge the gap to more like numeric type optimizations that you're talking about, Paulo, where you're like, well, this is actually like just a really complex SQL query. Um, but the problem is a lot of humans have problems with writing really complex SQL queries, right? Because it requires quite a bit of reasoning. And I think SQL has done a great job of making data accessible to a lot of people because it has sort of this like it's like it's sort of the original low code language, right? Like this is something we talk
Yeah,
about a
so
lot in.
I was just remembering when you were giving your summary that in the 70s and 80s when it was, just being developed, it was marketed as like a natural language way of accessing your data, right? I think SQL means like structured English query language. So, it's incredible the the progress that we've made in that direction.
Exactly, and I think that was the original intent, and I think it has worked really incredibly well. Like if you look at like I think you can talk to a random crowd of developers, and most of them will have heard of or even used SQL relatively recently, right? It's very widely adopted and
Yeah.
widely used.
Sorry, and the same with ontology languages, right? Like description logics were also marketed that way.
Yes, and I think they had a somewhat harder time getting sort of the adoption that SQL was looking for, right? Because
Yeah.
it ended up being it ended up being a lot harder to understand what was going on, right? And it tended like, and then that's always the trade-off, right? Like how do you build a system that is easy to use for a human, but at the same time has, is a formal language that you can translate to an actual like compiler, and like in the case of SQL, like you need a query planner and it needs to actually map to relational algebra and relational calculus so you actually know how to execute it. Um, and that's, with ontologies, like, and, like if you look at like RDF and the semantic web and OWL and all these things, like they have that strong, frame logic background and basing. But like, I think it is fair to judge right now that they, didn't quite bridge the gap to wide user adoption because the learning curve for the human was too steep. And so while they're very successfully used in a lot of domains, like medical domains and things like that, they usually are reserved to like experts that can use those kinds of things, frameworks.
But to be fair, I think they do have different capabilities, right? So, relational databases or ontologies, they do guarantee that you get an answer that, you can trace back to the data and there's, this derivation. And with LLMs, I think the the next the challenge is to connect, like make sure that the answer they're giving is actually correct, right? So I think there are a lot of applications that you mentioned where it doesn't matter, as long as it's, you know, close enough, but other applications demand more guarantees.
Yeah, and that's why I think the two classes of problems that I outlined will have different approaches, right? Like on the front end side where I'm a user and let's say I want a decision support system. So let's say like a common scenario would be I work in a call center, people call me with various problems and I need to solve those problems, right? Like that's a great scenario where I want to have a lot of decision support systems that I can quickly use to like look up information about the customer that's calling me and system outages and whatnot so I can quickly triangulate what the problem is, right? And there I think it's important to find the right answer, the provenance of the answer for a particular caller interaction is not so important as long as it solves the actual problem that I'm having, right? Meaning I want to make sure that if I look up the customer information that I'm getting the right information, right? That would be terrible if I'm like in a medical billing department and I, like get information from some other patient, obviously that would be a horrendous breach of HIPAA and all kinds of violations, not to mention that I might inadvertently diagnose somebody with cancer who was just calling in about a bad throat. So obviously you want to guarantee that, but in terms of like deep provenance tracking, it's more, that's less of a problem. And the bigger problem is how can I get the data that this person needs to them very quickly, right? Without them figuring out what SQL query they need to write, or like what ontological query, like what
So
Sparkle query they need to do.
in that class of problem, what are the technical challenges? Where do we still need to do work to get, to go from LLM based, user input into, a proper query even for this kind of stuff?
Yeah. So, and I don't know the answer. I have some opinions based on what I've seen happening over the last sort of 3 to 5 years and how sort of the LLM development has accelerated. And like looking into my little crystal ball, my guess is that the foundational models are going to get better and better, right? Like if you look at sort of if you look at sort of the evolution from GPT-2 to GPT-3 to GPT-4, which are sort of the three major models that OpenAI released, right? It's quite apparent that they've gotten sort of orders of magnitude better. And I expect that with all the infrastructure investment and all the research that we're doing in this area, that these models are going to get better, they're going to get smarter. The part that we are still having a hard time figuring out is how do we give these models the relevant information they need to come to a good conclusion or to provide the necessary answer to a question that I have. And that's the area that I'm really interested in figuring out, because that's, I think, is the area between LLM and database, that intersection that we're trying to solve. And the initial work that was done in this area was very much focused around augmented retrieval type approaches. And what that means is, if you think about an LLM, like the way that they generally work is you provide an input, and then that input gets run through the LLM. The LLM does its token prediction and reinforcement learning style optimization, and then produces output tokens that get then returned back to the user. And so one thing that majorly impacts the quality of the result is basically what you put in that input context, right? It's sort of the context to the question. Like if I may use a human analogy, right? It's basically like you have your general intelligence, right? This is kind of your education and everything that you've learned over your life. And then you have sort of your short-term working memory, right? Like maybe you're reading a paper right now, right? And that's in your short-term memory. So if I ask you a question about the paper, you're applying your general intelligence and everything you know about research and academia and so on to the specific paper that you just read, right? And that's kind of how LLMs work, right? They have this general training, the neural network that gets trained with billions of parameters, and then you give it a context and a question, and that's called the prompt, and then it produces a response. And so the really interesting question is also, what do we put into that context? And it's an interesting optimization problem, because contexts are quite limited, right? The contexts are typically limited to about somewhere between 8,000 to 100 or so thousand tokens. Google has released a model recently that can take up to 1 million tokens, but there seems to be generally some kind of degradation, meaning the more you put into the context, the more the LLM can start losing the context, right? And the more it sort of it kind of strays from what you're giving it. So there is a strong incentive for the user to put exactly what is needed into the context so it produces the right answer. And that's kind of and that sort of kicked off a whole area of research around this whole, like, what do we actually put into this context, right? So if I ask a question, and like in the general search, if I ask a question about, I don't know, summarize all the research that Palo has done over the last 10 years, right? Like if I ask that question to an LM, if I just flat out ask that question right now to an LM, I probably get like an okay answer, but not a great answer, right? It's going to be very generic, probably mostly like what you put on your homepage and like things that it was able to scrape and has in its background knowledge, right? Like it'll give me like a high level sort of like thing, but it won't be able to really like deep dive into your specific research papers that you've written. If I can inject that into the context, right? If I give it the specific papers and say, hey, look, here are all the papers that Paolo wrote. Like, can you tell me what the general research themes are that he's working on? I will likely get a much better answer, right? Because then I can apply the general knowledge of the LLM to the specific context that I injected to answer my question. And that's the idea behind retrieval augmented generation. It's like put the right stuff into the context so that you get better answers, right? And there's been a whole class of research, and then there was this like, okay, how do we know what we need to put in? And there's various approaches. Some rely on vector search, which is basically kind of a semantic proximity scoring, right? Where we say, let's like look at what I'm asking and then embed that and then sort of treat that as a vector. And then I'm going to look at all the content that I have available and which content is semantically closest and things like that. There's other approaches that look at, like search query type retrievals, but basically there's a whole class of things of like let's figure out what the LLM might need to give me a better answer and shove that into the context up front. What's really what's really exciting now is that as the LLMs have evolved, we've actually been able to train LLMs to be able to more accurately tell us what they need. So before, basically, the LLM was kind of a black box, right? And we treat it as sort of a general intelligence, but it's kind of like it's like a room where a really smart person sits, right? And you have like 3 minutes of their time, so you can run in there, scream a bunch of stuff at them in 3 minutes, and then you get their answer, right? And you take the answer, you say, "Thank you very much, Oracle of Delphi. I'm good. I'm going to head out," right? Like that's kind of how we treated LLMs. And since then, we have made progress to be able to actually tell LLMs, hey, you can use these tools that are available to you to retrieve additional information that you might need. And so it's kind of like if you think about it, it's sort of the evolution from like high school research to like undergrad to graduate research, right? Where in high school, you would give a student a paper and say, hey, please summarize this paper for me. If you work with a grad student, you expect the grad student to be able to find those papers themselves, right? To use Google search, to use for us old school folks, a library, like find the books, find the relevant stuff, figure out what the provenance is, figure out whether it's relevant, and then, work yourself there. And that's kind of the evolution that we're going through with LLMs as well. We started off as that, like, we basically have to feed them the stuff and they do it, intelligent summarization, question answering. Now we're getting to the point where we can actually tell the LLMs, hey, here's the question, but here's a bunch of stuff that I can give you access to if you need to. So tell me what you need, and then I'll give you that data, right? So to stay with the example, I can now tell the LLM, hey, I want to know what Paula's been working on. And by the way, I have a function call where you can look up for, a specific author name and time period. I can return you all their papers, right? And then the LLM will tell me, oh, okay, let me look up for Paolo in the time period that I advertise, pull all the papers back, and then it will pull that into its context and then give me the answer. And that's, I think, where a lot of this stuff is going to be heading, is where we're going to be starting to work on figuring out smarter and smarter integrations to use this kind of tooling framework so we can help the LLM to pull in what is needed based on its understanding of the context.
So the thing you kind of walk through sort of makes me think about an LLM working with something like Elastic, where you have kind of, a corpus of documents, and you do something like, looking at vector similarity to identify a good set of documents. What about dealing with, a company's Oracle database that has a heavy schema, and instead of just looking for similar documents and summarizing the subset and kind of, just a way to find something interesting, maybe now I'm looking for some specific facts and I have structured data, just the user either doesn't have the time or the skill set to understand the schema and understand how to write a proper query.
Exactly. And that's, I mean, you're exactly hitting the nail on the head. I think the old school way, and by like old school, I mean, we're talking like 2 years old, right? Like the old school way was I'm just going to dump all my documents into Elasticsearch, do vector similarity, and just hope that I'm getting the right stuff out, right? And it's very limited because obviously I don't actually know what the user is asking for. I'm just doing at the end of the day, I'm doing a fairly dumb thing, right? I'm just saying, like, compute a flat vector embedding of this question. And the problem is that in a lot of cases, the questions aren't very descriptive, right? Like most users, in particular in decision support scenarios where, you're dealing with a customer or you're like under time pressure, they're not going to write you like a paragraph of text explaining in minute detail what they're looking for, right? So the vector embedding is not going to be very accurate, because usually you get like a, hey, what was the last 5 interactions we had with the customer kind of a thing, right? And vector search is not going to help you there very much, because it's not going to actually like be able to embed that with the actual, like if you put the actual customer interactions into Elasticsearch, as you said, Paolo, like a vector search is not going to be able to pull them out. And so we're looking into taking the new approach of giving the structured data that we have, structured, semi-structured, unstructured, doesn't really matter, and exposing it through this tooling interface that the LLMs expose. So they have direct access to that information and can pull it in as needed. And the other thing that allows us to do is to then put a sandbox, so to speak, around the data that they can have access to, so that for certain scenarios like healthcare, government, et cetera, you can make sure that the data that is being pulled in has the proper authentication and authorization requirements enforced, right? Like, because you don't want your LLM to just have root access to an Oracle database and just query whatever data it deems necessary to answer a question, right? Like that would, in a lot of cases, like medical, government, et cetera, that would be considered a pretty serious data breach. So we are working on figuring out like how can we build basically a new type of interface between LLMs and databases so that LLMs are empowered to pull out the data that they need while still giving us humans, so to speak, the guarantees and sort of the peace of mind that we need to make sure that that data transfer happens correctly, that it
But
happens
also,
consistently.
also the fact that, currently, or at least, up until like you said, maybe 6 months ago or whatever, there were the big issue with LLMs is that, if they don't know the answer to something, they'll just make it up, right? Like
Yes,
hallucinations.
that's still a huge issue. Yes.
Right. I know it's an issue, but at least have them say that they don't know. I think that would be a huge step forward, right? So I don't know what do you think personally? Is there any hope for that, like to completely solve the hallucination problem?
I think, I mean, completely solve is always, that's always
Yeah, well, yeah.
like like we're dealing like in this world, like everything is a probability, right? So it's like, like what is the margin of confidence that we can get to? I think we can do a lot better. So there's two developments that have happened. One is that like through tooling, we can give the LLM a better escape hatch to say, hey, I don't know, let me try to figure it out. Um, and you can, through prompt engineering and fine tuning, make sure that the LLM takes that route more often than not, so that you don't have the problem of like, oh, I don't know exactly what the user is asking for, so let me just kind of make some stuff up, right?
Right. I mean, it
Like
leaves
if you,
the data management realm, right? When you don't use data to answer your questions like SQL style, then you're just, in the probable next token realm, which is, quite different.
yes, exactly, and the LLMs by way of how they are built, they will always try to come up with something, right?
Right.
And so that is a huge problem, in particular as you get into domains where the knowledge of the LLM starts to deteriorate, right? Like, because most LLMs are trained on like web data and like publicly available data, books and so on and so forth, right? They will, for obvious reasons, not have any company internal data, but even like when you go into deep sort of specific areas of knowledge, they tend to thin out pretty quick, right? And so being able to augment that through these kinds of tooling interfaces is going to be, I think, one big element to giving the LLM that kind of escape hatch and say, hey, I don't know, let me look this up, right? And I think that's kind of like, again, like if you look at like human development, right, that's an important part of learning as well, right? Like I remember, when I graduated from high school, I thought I knew everything. I thought like, this is gonna be like I know everything about everything. I'm just so smart now. And it's not until like you really get, into your fourth year of your PhD when you're like, I have no idea what I'm doing.
Hmm.
Like, but that kind of like evolution needs to happen with LLMs as well, right? Like the way that they are trained, they're kind of like that like, I just aced my high school exam kind of a personality of I know so much, so broad. Tooling will definitely help. The other thing that has happened is that we can now get the logic probabilities back out of these models, right? So we can look at what the actual prediction frequency was for the tokens and identify areas of low probability. So we can say, hey, this area the LLM wasn't actually very certain about. Because that's the part that we are losing right now in the interface. Because when you get an answer from LLM, it sounds so confident all the time, right?
Yeah.
It will tell you something. You're like, yeah, absolutely, that makes so much sense, right? And then you talk to an expert, and they're like, no, that is well made up nonsense, right? And that's very dangerous, right? Because it's a lot easier to identify pure nonsense, right? If you just get gibberish, right? Like if you have like, somebody
Yeah.
just kind
Random
of say the
letters. Yeah.
words but loosely, you're like, okay, I know that's gibberish. But if somebody is like smart enough about a domain that they can make really coherent type looking arguments, but their like premises are wrong, the axioms are wrong, that's really dangerous.
So as you talk about this kind of tooling, for an LLM to interact with, a company's data, for example. Um, I would imagine that there's probably some sort of is there code generation, whether it's SQL or something else coming out of the LLM, or or is there some other way that you're handling that? Like, how do you determine the right query to make based on the LLM? And kind of with that, kind of getting back to your other use case, um, how do you make decisions on solving a problem like not related to a simple query? How do we get into that area? How does the tooling look like there?
Yep. So right now, the LLMs, pretty much all major LLMs are being trained on what's called function calling. And so they basically are being trained on these function signatures that they can call, which are annotated with information to say what this function does, what the arguments are that it expects, and so on. And so what we developed and open sourced is basically a framework that allows you to translate that to the database through an intermediate API interface. And so we basically build technology where you can write, like your data pipelines and your SQL queries and whatnot, and then it'll automatically translate that to this kind of syntax and interface style that the LLM expects, so that as a user, you don't have to do that extra work of plugging it all together. Like, we can do that automatically for you. And so that gives you kind of a translation layer. And ultimately, we think of that as the new interface to the database, right? Where on the one side, you define what data you want to expose and how. And there has to be, for now, and I think for some time into the future, there has to be some kind of semantic annotation that needs to happen there, because you need to give it context and the domain knowledge that the LLM needs to actually ground that data into, what that data does, right? Like if you think of it like an Oracle, like to your example, like an Oracle table, it's not super descriptive because all you have is the table name and the column names and the column data type, right? And if you look in a lot of organizations, the column name is like price underscore P, price underscore T, price underscore K. So like, okay, but what does that mean? And then, you talk to the expert and say, oh, yeah, we have like 3 pricings for, this, that, and the other thing. And historically, they've grown down a lot. That context, like that semantic annotation needs to happen somewhere, right? And so that's what we do in our framework. We give you the ability to do that. Oftentimes, you also want to process that data somehow. You don't want to just kind of give the LLM like a flat table, because oftentimes you want the data to be more particularly suited to a use case. That's currently required because LLMs are not as good yet. So if you just give it sort of generic data, like the answers you're getting are not as good as if you prepare the data well, right? So the point I'm trying to make is that you get a lot of bang out of, or you get a lot of money returned if you can carefully prepare the data versus trying to have the LLM figure it out. One is the pure economic argument. LLMs are very expensive, right? So the more that you can do on the data preparation side, which is very cheap comparatively, the more money you're going to save. Right? Like some people think of LLMs as these like things that can do everything, and they somewhat can, but they're very bad at like math type things, right? Like, and by very bad, I mean they don't do them well internally. Like probabilistic models aren't great for doing like deterministic type of inference, but also it's just so incredibly expensive to do that, right? It's like millions of times more expensive than just like doing the math in a computer on the CPU. And so you want to be smart about how you expose that data. And that's kind of the framework that we build, is making that really easy for you to say, oh, I have my Oracle table here and my customer table, my purchase table, my orders table, and I have a Kafka topic and some other files that I want to expose. We make it really easy to combine that data and expose it in a way that's good for an LLM to take as input. Because that part, and this kind of goes to your original question, I think a lot of that, how do I, like, what data do I expose and how do I expose it? That's still something that we will do for quite a long time as a human, either fully as a developer or assisted by an LLM, because you want to have some guarantees around that part, right? Like you want to have some guarantees around what is the data that actually makes it to the LLM, and how can I have provenance and governance around all that whole aspect, so I make sure that the right data is coming through, that I can debug after the fact, right? If the LLM does give a wrong answer, how do I know what went wrong and how do I fix it? Like those kinds of things will be concerns for I think a very, very long time. And that's kind of the where we see this kind of shake out is like the LLM is the ultimate translator and the ultimate human interface, but you still want to do a good amount of data processing and data preparation and data cleansing that requires deep domain expertise to be done upfront so that you can A, amortize the cost of doing that, and B, have guarantees around what the actual results are.
So when you're using the LLM to kind of interface, with this layer that you've built that allows, talking to these data sources, um, how, do you ever run into issues where the LLM maybe has like some kind of syntactical issue, because yeah, these things are trained on a lot of code where they can generate functions, but what if it generates a function call and it flips the arguments in a non-symmetrical function and it causes a weird result or causes something not to be even executable? Like, how do you deal with errors like that? Or is that not a problem for some reason?
Um, no, I think the right now there's sort of the like what's the current state, what's the future? Like right now, we find that you still want to keep the interface really, really simple so that these kinds of problems um, don't arise so often. So like to give you a simple example, like we use LLMs for two things. We use them to pull in the right information and then kind of figure out how to present the information as best as possible to the human user so that they best augment the support, the question that the user has. And so one of the options for doing that is to say, hey, I'm going to visualize this data, right? Because that's a very good way for humans to perceive data. We're usually a lot faster at perceiving information in sort of some graph form than reading a table of data, right? Like if I give you, like if I ask you, I don't know, like if you have a question around like, give me, how much inventory we've moved over the last, 6 months by day. Like if I give you a long table with like, hundreds of rows, that's going to be a lot harder for you to perceive than if I give you a graph that shows, how that data works. And so we're asking the LLM to do that. It does it really well current state of the art. Most models do a really good job of doing this with like one-dimensional visualizations, right? So like plot data over time or plotted by category or something like that, right? Like a simple one-dimensional thing. When you get to 2 dimensions, we see a much higher error rate come up, where the model isn't quite able to figure out how to correctly transpose the data, or does something weird where it injects the labels where it shouldn't be, or the labels don't line up. Like we see a lot higher error rate occurring, right? And so that kind of gives you that somewhat answers your question in the sense of like, yeah, like we see a much higher error rate, and only like GPT-4, for instance, is able to do it really well. Some other models, like in particular, like we tried it on Llama 3, 7 billion, doesn't do so well on it, right? 70 billion does a little better, but definitely not as good as GPT-4. So there's still a huge variance in how good these models are in sort of doing the interface. So and that's still pretty trivial stuff, right? We're really just talking about like how do you take data and like transpose it and mutate it so that you can pass it to a plotting function, right, correctly. When it gets to much more complex things, I would imagine the error rate would even go up further. And so for now, I think you're better off pushing that into the database than trying to have the LLM do that on top, right? And that's kind of what we're trying to enable to make that really easy. I think it's going to be a moving target, right? Because there's sort of the more you're trying to push in the database, you lose in terms of flexibility, right? Because then you have to expose it in a way that the LM can access. The more you give to the LM, the more the LM has flexibility, but then the flexibility has the downsides of A, it can make mistakes, B, it can hallucinate, and C, the provenance of whatever it's returning goes down because it can do whatever, right? And so I think that's going to be an interesting area to watch as this technology matures, as to where do we do what, and how does this line move. um and yeah, and I think there's the now answer of like right now you still want to be pretty prescriptive about what you allow the LLM to do. In the future, as these models get better, I think we'll see some of this kind of move towards the LLM and you giving it more flexibility with respect to data access.
So, we're getting into kind of the last 10 minutes or so of the show here, I thought maybe this would be a good time to shift gears a bit. So, Jerry and I left grad school and we went, to academia. And you leave grad school and you go and start a company and you built something and you led a firm as the CTO on the public market. Um, you know, I think kind of two parts, what led you to do that? Because you were a pretty accomplished researcher as you were earning your PhD and probably could have done what Jerry and I did. And then at the same time, what advice would you give for other people who are trying to make that decision and thinking about entrepreneurship as they finish their graduate degree?
Wow, that's a really, really good question. I so I would say I think it really all comes down to what you enjoy doing at the end of the day, right? Like I think that like for me, even in grad school, it was interesting. We were all sitting in the same room, right? But I think there was a slight difference in that I always admire you guys for like you guys were really just able to churn out papers and write papers, and I always had a much harder time with that. I love building systems, right? That was that was kind of the thing that I was really excited about. I love building, like the what later became Titan and then Janus Graph, like the early, like that was really what I was excited about, and and then the whole part of like coming up with the research narrative and
I
I got
admired that
so
about you, by the way.
really. It's
Yeah.
like I was really lucky to have VS because he was really great at coming up with these bigger narratives. I was always like, man, I love to build these systems, and he was really good at like helping craft that narrative around it. And so for me, after the PhD, I mean, having been in academia, obviously there was sort of like, okay, I should do a postdoc and kind of go that route. But I just felt like a strong pull towards like I want to like actually see these systems being used, right? Like that was something that I really, really enjoyed. And I think that's for me, that was sort of the demarcation line. I think in research, you have a lot of flexibility and in some cases much more flexibility to explore new ideas and really go out and do some groundbreaking new research, but it's much harder to get people to actually use your stuff, right? Like it's because you're hoping, for commercialization and like Paulo, as you know, you can't just like throw a research idea over the fence and say, hey, go like build this thing, right? Like that, like the translation from research to industry is really, really tough. And so I always felt like there was some loss when those ideas weren't getting translated, right? Like that there was some kind of like that, like to me that felt like an emotional loss almost, right? Where I was like, I'm not happy to just write a paper and then get a best paper award and people are like, hey, awesome research. Like, yeah, but nobody's using this. Like, like this isn't helping anybody right now. And so that was for me, that was a strong emotional pull to say, hey, I want to actually see these things become things that help other people accomplish tasks, right? I personally felt that was easier for me to do in industry. I think there's definitely routes to do that through academia. I think there's some folks that are really, really excellent at at doing that bridge and transferring that knowledge. Um, and some people that have are really strong in both worlds, right? Like I think there's definitely some regret on my side to say, hey man, it would have been nice to kind of keep some of that research alive, right? And having sort of something where you can just kind of go out and do crazy things. You're more limited to do that. Like at DataStax, I was very fortunate that we had the budget to go out and try some crazy ideas and do something on the side, but it is always more focused on what is the tangible customer value. You can't go
Okay.
out and say, I'm just going to do something crazy and who knows if that's going to lead to something, right? That's really hard to do, right? Like the Bell Labs days are somewhat over. It's really hard to come up with just some random idea where you just kind of, have a bunch of smart people sitting in rooms and, whether they produce something of commercial value is irrelevant. I think those days are a little over. And so there's pros and cons is I guess what I'm trying to say. It's like I don't know that I have a good sort of sense other than saying like see what pulls you emotionally, right? Like what is it where, you know, what are you more willing to give up, I guess, is the thing, right? Like there's definitely parts of me where I'm like, man, I would love to just kind of spend the time and just go through the VLDB journal and like catch up on like what's been happening, right? Like the way
There's
I read
always time.
VLDB these days is pretty pathetic. It's like skimming the headlines. And it's like, okay, moving on to like 5 meetings now.
I could hear you there, but no, thank you so much for that. I mean, I know we do have a lot of viewers that are kind of at that juncture, and I see, some of them email me and comment, and that's part of the reason why I thought you would be an excellent guest. So,
Thank
thank you
you.
so much for your time today. I really appreciate it.
Yeah, thanks,
Absolutely. It was a
Matthias.
pleasure to be here. Thank you guys.
Interesting
All right.
stuff.
Well, thanks again for tuning in, and don't forget to like and subscribe.